So now we are talking about two random variables, and we want to find the joint PMF. So first we need to know the x and y. X is the maximum of two numbers. So maximum two numbers, so either actually is still either 1 or 0, because if I throw the coin twice and got tail twice, then I got 0. So x could be 0 and 1. And also y could be 0 and 1. First, you have to know the sample space for x and the sample space for y. Now, I want to find the PMF. So the notation for PMF of xy, because it's discrete, so it's the probability of x equals certain point 0 or 1, y equals certain point, say y equal 0 or 1. So now I want to find first if x and y are 0 and 0, because we have 0 and 0. That means my probability x equals 0 and y equals 0. And we need to know that they are independent, because each flips a fair coin. So they are independent. That means I have the probability of x times the probability of y. So you'll get the probability equals 3 divided by 16th. Why do we have like 1/4 and 3/4? You need to think about, because the maximum of two numbers and the minimum of two numbers. I leave this for you to think about. Why x equals 0, the probability is 1/4, and the probability of y equals 0 is 3/4. Again, we want to find the PMF. This is one of the PMF for certain point. We need to still consider if x equals 1 and y equals 0, which means x equals 1, y equals 0, because they are independent again. So this is probability of x equals 1 times probability of y equals 0. And here is 3/4, which is 9/16th. And also x equals 0, y equals 1. That's the probability of x equals 0, y equals 1. And it's 1/4 times 1/4 is 1/16th. And that is x equals 1, y equals 1. Same here, we have 3/4 times 1/4, which is 3/16th. So you make sure that this PMF is valid and correct. You add them together. You add those PMF. This one plus this one plus this one and plus this one. So the summation is 1, which is correct. They satisfy the properties of a PMF. Next, find the marginal PMF. So the marginal PMF of x is, as summation out the y. So it's the join the PMF, but as some OY, which means the y is either 1 or 0. So that means assume x0 and x1. So we also know that x is either 1 or 0. So now we have the PMF of 0, which is the PMF of 0, 0 plus PMF of 0, 1, which will be 1/4. And the PMF of 1, x equals 1. Same thing, there's a summation O y out. I sum O y. So, well, that means the PMF of 1, 0, and 1, 1, which is 3/4. So now you have the marginal PMF of x, and you see this is 1/4 and 3/4. 1/4 when k equals 0. Well, if I have k here, k equals 0, and if k equals 1, the probability, the PMF also probability is 3/4, and you can verify it. I sum those together equals 1. So it's a valid PMF, so which is correct. So similarly, we can find the marginal PMF of y. This one, then you can do it yourself. You just change x and y. The x now is y, and y now is x, and then you can easily find the marginal PMF of y. Now, the part C, the conditional PMF. Let's see. The conditional PMF is probability of x given y. From the basic definition, that's the probability of joint PMF divided by PMF of y, marginal PMF y. So again, we just plug in because that's discrete. So x could be 0 and y could be 0. X could be 1, y could be 1. That means if I have a 0 conditional on 0, then you plug in to those values we got from part A and part B. We can have 1/4. And also, if it's 1 given 0, then the answer is 3/4. And 0 given 1, then I will give you 1/4. And 1 given 1 will be 3/4. And we know that the probability of x is like px 0 equals 1/4 from part B, and then px of 1 equals 3/4. So they are totally different because we have 4 numbers here and then I only have 2. And also you can verify that if I add those together, finally not too much. If I add this two, there'll be 1. If I add those, then it's still 1, which is valid, because if we fix the given point, then this is also the valid conditional probability. And Oh, so you can also realize that those are the same. When x equals 0, then I got 1/4, 1/4. When x equals 1, I got 3/4, 3/4. Why? Actually, that's the same. Because they are independent. X and y are independent. So x and y independent. So the conditional PMF x given y is just the PMF of x, because I doesn't care about y.